WIMPs. What are they? WIMPs are one of the most popular candidates for what physicists believe dark matter to be made of. However, to fully understand what exactly WIMPs are, we must first understand what exactly dark matter is.
In 1933, Swiss-American astronomer Fritz Zwicky inferred that the mass of all the stars in the Coma cluster of galaxies produced only 1% of the mass needed to escape the cluster's gravitational pull. This observation is caused by an idea of Einstein's theory of relativity, where the more mass something has, the more it magnifies and distorts objects that can be seen through it, resulting in the idea of this invisible matter, which we call dark matter. However, its existence remained in question for decades, until the 1970s, when American astronomers Vera Rubin and W. Ken Ford confirmed its existence by observing a similar phenomenon. The mass of the visible stars within a typical galaxy was only around 10% of the mass necessary to keep those stars in orbit around the galaxy's center. This puts forth the phenomenon of gravitational lensing, matter acting as a lens to distort and refract light by bending space.
From observations, two types of dark matter have emerged. However, most of it is made up of a non-baryonic form. This non-baryonic dark matter has proven to be made up of heavy, cold particles, cold in this case meaning slow. There is also an absence of light when looking at this matter, which means they're most likely electrically neutral. This electrically neutral nature also means that they most likely interact using weak nuclear forces and gravity. These properties hence give the name WIMPs: weakly interacting for their weak forces, massive for their heavy cold nature, and particles because, well, they're particles. Although they are not a part of the standard model, the idea of supersymmetry, which predicts that each particle in the standard model also has a partner particle, may prove the existence of WIMPs. Using the predictive properties of the supersymmetric WIMP to calculate how many would still be around today, the result is something that closely matches the experimentally observed amount of dark matter. This coincidence, which is believed by many to be more than just a stroke of luck, is known as the WIMP miracle. However, the overlying issue is that all the evidence we have on WIMPs so far is indirect, being only able to observe its effects from space. Researchers have been desperately experimenting and testing, using equipment such as the Large Hadron Collider at the CERN facility. Unfortunately, no solidifying proof of WIMPs has appeared. As a result, WIMPs are slowly being left behind for other potential candidates, including axions, sterile neutrinos, and more. But who knows, maybe one day we'll discover what dark matter is truly composed of.